Good morning to one and all. See this in this today's live lecture. First of all, I welcome all the students, that is in properly Digambar Imde, Rutuja Kaldate, Preeti Birazdar, Pooja, Vaishnavi, Mukund, Seema, Harish Khan. Now see this in this today's lecture, we shall study the examples, more and more examples based on comparison test of integral. Actually, we have studied different tests of improper integral for the convergence of integral, and by using that comparison test we have to solve some problems. See this, actually we have seen in this last chapter useful comparison integral. Before that also we have studied comparison test first, comparison test second. Also we have proved one theorem, that is a convergence of given integral at infinity, and using that all theoretical part, all this theorem, for the confirmation of a theorem we have to solve some problems. In the last lecture we have also solved some problems based on that. Now see this, actually in the improper integral we have studied first theorem, that is limit integral from a to infinity f dx. If this improper integral converges, then limit x tends to infinity integral from a to x f dx must be exist. Then only we can say that given improper integral is convergent. Then we can say. Secondly, the convergence condition, comparison test for the convergence is, this is the second theorem. See this, limit x tends integral from a to infinity f dx converges if integral from a to x f dx, where x tends to infinity, capital X tends to infinity, and integral from a to x f dx, which is less than m. M is the positive real number for all x greater than a. If this integral is less than some real number, then we can say that given improper integral is convergence. This is the theorem of convergence at infinity. We have studied this. Secondly, if f and g are two positive functions such that f of x is less than or equals to g of x, that is there is a comparison between f of x and g of x. F of x is less than or equals to g of x, then we can write if here, if f of x converges, इथं महत्वाचं second condition पहा, if g of x converges, then we can say that the integral from a to infinity f of x dx converges, because g of x is greater than f of x, and if g of x converges means it has a limit, real limit, its value is less than some real number m. So we can say that f is also less than some real number, so we can say integral from a to infinity f dx also converges. Secondly, if integral from a to infinity f dx diverges, then we can say that integral from a to infinity g dx also diverges, because f is smaller than g. If f goes to infinity, then definitely we can say that g goes to infinity. Secondly, second comparison test second, that is in the limit form. If limit x tends to infinity f of x divided by g of x, which is equals to L, where L is a non-zero finite number, means L is any finite number, finite limit, then integral from a to infinity f dx and integral from g to infinity g dx, both the integral converges or diverges together. Both these integrals are converges or diverges together. This is the very important condition. If L tends to 0, means limit x tends to infinity f of x divided by g of x, L tends to infinity, f of x divided by g of x, then g of x converges, then integral from a to infinity f of x also converges. If L tends to infinity and g of x diverges, then we can say that integral from a to infinity f dx also diverges. Also, one useful comparison theorem is integral from a to infinity c divided by x raised to n, and if the value of n is greater than 1, then we can say that given improper integral is converges. If n is less than or equals to 1, then this given improper integral is diverges, which we have proved. Okay. आता याच्यावरचे प्रॉब्लेम्स आपण काल पाहिलेले आहेत. नंबर ऑफ प्रॉब्लेम्स वी हॅव डिस्कस्ड. ॲडिशन मध्ये काही प्रॉब्लेम्स आहेत ते आपण इथं या ठिकाणी घेऊ, या ठिकाणी सॉल्व करू सिरीज. Okay. Now next, integral of, we shall discuss the next example. That example is, 1 minute, integral from x square into e raised to minus x dx, an integral from 1 to infinity. See this is actually improper integral. कुठे improper integral आहे रे स्टुडंट? नाउ यू टेल मी at which point. हे improper integral कुठल्या सेक्शनला आहे? लेफ्ट एंडला आहे का राईट एंडला आहे? See this given integral is improper at right end. That is I is equals to integral from 1 to infinity x square into e raised to minus x dx. Let f of x is equals to, we can write integral from, आता या ठिकाणी f of x चं कंपॅरिझन घेऊ. f of x is equals to x square into e raised to minus x. This is the f of x. Now we consider, if we put x is equals to infinity means right end, then this goes to the infinity. This goes to the infinity. So our integral is improper at the right end. Okay. So we can write, consider the function which same behaves like this function g of x, which is equals to 1 upon x square. Then we shall take the limit f of x upon g of x, f of x upon g of x. Now limit x tends to infinity f of x divided by g of x, which is equals to limit x tends to infinity x square into e raised to minus x divided by, suppose we can take this, that is e raised to minus x upon x square. So this is a limit x tends to infinity 1 upon e raised to x, and which tends to, see this, the value of this as x tends to infinity, then 1 upon e raised to x, 1 upon e raised to x tends to 0. That means this goes to 0. So we can say that the value of, therefore limit x tends to infinity f of x divided by g of x tends to 0. Then according to the, this comparison test second, having the special case, if f of x divided by g of x tends to 0 and g of x converges, then we can say that f of x is also converges. आता मला सांगा g of x convergence आहे का divergence आहे पहा. Now by the comparison test second, नाही एक मिनिट. Now integral from, what is the lower limit, 1 to infinity g dx, which is equals to integral from 1 to infinity 1 upon x square dx. आता 1 upon x square dx हे कॉन्वर्जंट आहे का डायव्हर्जंट आहे रे स्टुडंट सांगा. वी हॅव टू यूज दिस युजफुल कंपॅरिझन. 1 upon x raised to n, if n is greater than 1 then it is a convergent. Same problem you have to use 1 upon x square. X square means n is greater than 2. Here n is greater than 1. So converges. So converges. By the comparison test second, integral 1 to infinity f dx, which is equals to integral 1 to infinity x square into e raised to minus x dx converges. Okay, Harshad Dalvi, Omkar Birazdar, Prithviraj Jadhav, very good. So we can write this same problem. Now we can solve this problem also in this way. Secondly, if we consider the value, second, integral of 1 to infinity x raised to n into e raised to minus x dx. Same problem. Now we can consider the behavior. Let I is equals to integral from 1 to infinity x raised to n into x raised to n into e raised to minus x dx. This integral is improper. कुठे आहे तर स्टुडंट लेफ्ट हँडला इम्प्रॉपर आहे का राईट हँडला इम्प्रॉपर आहे. दिस इंटिग्रल इज improper at the right end So we have to use the property. Let f of x is equals to x raised to n into e raised to minus x. Now we consider another function g of x, which is as like a same behavior, 1 upon e raised to x, as like this is also written as x raised to n divided by e raised to x. E raised to minus x means we can write x raised to n divided by e raised to minus x. Now how we can compare this? We can consider a function which is in the form of 1 upon x raised to n, which is in the form of 1 upon x raised to n. आपण लक्षात येतं का स्टुडंट्स 1 upon x raised to n च का घेतो? Why we can take the g of x which is in the form of 1 upon x raised to n? Because we have to use useful comparison test, useful comparison integral, because we have proved one useful comparison integral which is in the form c upon x raised to n dx converges if n greater than 1. So we have to compare this given function with the useful integral as like 1 upon x square, 1 upon x cube, 1 upon x raised to n. So consider the function g of x which is equals to 1 upon x square, which has the same behavior with f of x. So now we have to calculate the integral. अभी हमें क्या करना है? इंटीग्रल निकालना है. इसका कैलकुलेशन में इंटीग्रेशन निकालना है. So how we can take the integrals here? X raised to minus 2. So we can take this integral one minute, ठीक है. Limit x tends to infinity f of x divided by g of x, which is equals to limit x tends to infinity x raised to n into e raised to minus x divided by 1 minute, g of x means x square, which is equals to 1 upon x square, which has the same behavior with f of x. So we have to calculate this value, which is equals to limit x tends to infinity, त्याचा रेसिप्रोकल घ्या x स्क्वेअर इंटू ई रेज टू मायनस एक्स इंटू आता 1 अपॉन x स्क्वेअर आहे, that can be written as a x square minus 1. Sir, now we shall discuss the second problem. Now we have to discuss these problems. What is that problem? Integral from 1 to infinity x raised to n into e raised to minus x dx. That means same problem as like this, only in place of x square we have to replace x raised to n. So consider this integral is I. This integral is improper at the right end. F of x is equals to x raised to n into e raised to minus x. That means x raised to n divided by e raised to x. Consider the second function g of x, which is 1 upon x square, which has the same behavior. You can take 1 upon x cube, 1 upon x raised to 4, there is no problem, which has the same behavior of with f of x. Now we have to calculate limit. Limit x tends to infinity, f of x divided by g of x, which is equals to x raised to n divided by 1 upon x square. So we can write this as a limit x tends to infinity, x raised to n e raised to minus x into x square divided by 1. 1 upon x square means we have to take the reciprocal. आता या दोघांची ॲडिशन होते, so we can write limit x tends to infinity, x raised to n plus 2 into e raised to minus x. So limit x tends to infinity, x raised to n plus 2 divided by e raised to x. Now you can use the L'Hospital rule. So by the L'Hospital rule, limit x tends to infinity, काय तर याचा डेरिव्हेटिव्ह x raised to n चा डेरिव्हेटिव्ह सांगा रे स्टुडंट. Now you tell me the derivative of x raised to n. How we can take the derivative of x raised to n? See this, n plus 2 into x raised to n minus 1, n plus 1 upon e raised to x by L'Hospital rule. Again you have to take the L'Hospital rule. So limit x tends to infinity, n plus 2 into n plus 1 into x raised to n divided by e raised to x. Again if we take the continuation in the derivative by L'Hospital rule, then we get continuing in this way. Same process में अगर आप continuation करते हैं, then we get limit x tends to infinity. आता परत सेम प्रोसेस मध्ये जावा, L'Hospital रूल वापरा, then we get n plus 2, n plus 1, n plus n minus 1. In this way, dot dot dot, we can write 1 divided by e raised to x, and which tends to 0. So limit x tends to infinity, f of x divided by g of x. If we use continuously L'Hospital rule, then we get this term. And if we put n tends to infinity, x tends to infinity, so any term divided by e raised to x, x means 0, means it goes to nearly about 0, nearly about 0. So here we can write, so by here also integral from 1 to infinity g dx, which is equals to 1 upon x square dx, n is greater than 1, converges. Then by the comparison test second, बरोबर आहे वैष्णवी कोपले, very good. By the comparison test second, we can write integral from 1 to infinity f dx, or 1 to infinity x raised to n into e raised to minus x dx, converges. In this way we can obtain the given integral converges. Okay. Next we shall discuss the next problem. Third, integral from 1 to infinity, 0 to infinity x divided by 1 plus x bracket cube dx. Now we shall discuss the integral of this function. Here let I is equals to integral from 0 to infinity x divided by 1 plus x bracket cube dx. Student, now you tell me at which point this integral is improper. कुठल्या point ला improper integral आहे सांगा. This integral is improper at right end only. So we have to check the convergence. So we have to check convergence at infinity. So we consider the another function, that is here let suppose f of x is equals to x divided by 1 plus x bracket cube. Now we shall take the equivalent function, another function g which has the same behavior with respect to f of x. We have to consider, see this, f of x is equals to x divided by 1 plus x bracket cube. Now which is equivalent to x divided by 1 plus x, we consider x, that is x cube, and which is equivalent to 1 upon x square. So consider this as a g of x. We have to consider the another function g of x which has the same behavior. So consider the function g of x which is equals to 1 upon x square. See this, according to this comparison which has the same behavior, with f of x. Okay, there is no problem. Now we have to find out the limit f of x and g of x. आता आपल्याला limit find out करायचे. Now limit x tends to infinity f of x divided by g of x. Now we have to consider the limit f of x divided by g of x. Put the value f of x means limit x tends to infinity, f of x means x divided by 1 plus x bracket cube. G of x means 1 divided by x square. So we can write limit x tends to infinity x divided by 1 plus x bracket cube into x square divided by 1. So okay, right hand. So we can write limit x tends to infinity, that can be written as a x cube divided by 1 plus x bracket cube. Now see this, there are only algebraic term, ex term. You can use here L'Hospital rule for this limit also, or we can take the highest power common from the denominator, because we know that as x tends to infinity, then 1 upon x tends to 0. You know that this is the standard form of limit of integral for the algebraic function. If x tends to infinity, then definitely we can take 1 upon x tends to 0. So we can use this, that is x cube divided by, take out a common x cube from denominator's bracket, then x cube in a bracket 1 plus 1 upon x, or it is also written as 1 upon x plus 1 bracket cube. So this x cube will be get cancelled, then remaining term is limit x tends to infinity 1 upon x plus 1 bracket cube. As x tends to infinity, then 1 upon x tends to 0, then what will happen? 1 upon 0 plus 1. That means we get the value, therefore, किती आली रे limit ची value? Student, now you tell me what is the value of limit x? F of x divided by g of x, actually which tends to value 1. And f of x and g of x ची value 1 आहे. 1 means actually real, that is a L. Then according to the, see this comparison test first, if f of x, see this, use that 4 number note number 4, f of x divided by g of x which is equals to 1, where L means L is a non-zero finite number, so L get 1. Then f and g converges or diverges together, that means both having the same behavior. So we can use this property. So, and integral from which that value 0 to infinity g of x dx, which is equals to integral from 0 to infinity g of x means what we have taken, x raised to square dx. आता हे सांगा बरे, g of x convergence आहे का divergent आहे? Student, now you tell me. n is greater than 1, so divergent, so convergent, sorry. So it is convergent if c upon x raised to n dx, if n is greater than 1, then it is convergent. Then by the comparison test second, integral from 0 to infinity f of x dx, or which is denoted by integral from 0 to infinity x divided by 1 plus x bracket cube dx converges. Okay, this is the convergent. Okay, next we shall discuss the next problem. आता आपण पुढचा प्रॉब्लेम घेऊ. See this, we can write next problem, problem number 4, integral 1 to infinity dx divided by 1 plus x into root x, 1 plus x into root x. Okay, so हा सांगा रे स्टुडंट, हा इंटिग्रल कुठल्या एंडला, राइट एंडला का लेफ्ट एंडला कॉन्वर्जंट आहे बघा, डायव्हर्जंट आहे पहा. लेट I is equals to integral from 1 to infinity dx divided by 1 plus x into root x. So integral from 1 to infinity dx, okay, no problem. This integral is improper, right? This integral is improper at right end only. So we have to check convergence at infinity. Okay, we have to check the convergence at infinity. So let f of x is equals to 1 upon 1 plus x into root x. Now consider the another function g of x. Consider the function g of x. Now how we can consider this is, we shall discuss here. Suppose here f of x which is equals to 1 upon 1 plus x into root x. So So we can take approximate function which has the same behavior, that is x 1 plus x. This 1 plus x is considered as x into root x. So which is approximate equals to 1 upon x raised to 1 into x raised to 1 by 2, means x raised to 3 by 2. Consider this is equals to g of x, which is approximate equals to f of x. So we consider g of x is equals to x raised to 1 upon x raised to 3 by 2, which has same behavior with f of x. Now we have to calculate the limit. अभी क्या करना है आपको? लिमिट कैलकुलेट करना है. Now limit x tends to infinity f of x divided by g of x, which is equals to limit x tends to infinity. आता परत हे घ्यायचं, x tends to infinity. What is the second values here? The second value is f of x divided by g of x, means f of x is 1 upon 1 plus x into root x into g of x, means 1 upon x raised to 3 by 2. So we can write x raised to 3 by 2 upon 1. So limit x tends to infinity, x raised to 3 by 2, x raised to 3 by 2 upon 1 plus x into root x. Okay. Now you have to take a common x from this. Limit x tends to infinity, x raised to 3 by 2 as it is. If we take the common x, x into 1 plus 1 by x, or it is also denoted by 1 by x plus 1, again root x as it is. So limit x tends to infinity. Now see this, x into root x, we can write x raised to 3 by 2. Here in this case we can write x raised to 3 by 2 upon x raised to 3 by 2 into 1 upon x plus 1. So this get cancel. Limit x tends to infinity, 1 upon 1 plus x plus 1. Now as x tends to 0, then 1 upon x tends to infinity. So we get limit x tends to infinity f of x divided by g of x, which is equals to limit x tends to infinity 1 upon 1 plus 1 by x plus 1, that is 1 by 0 plus 1. Since as x tends to infinity, then 1 upon x tends to 0, that is equals to 1. Now if by using the comparison test second, limit x tends to infinity f of x divided by g of x is equals to 1, then L is equals to 1 in this case, then we can say that f of x integral from same integral f and integral g having the same behavior. In this case g of x is convergent, so we can write f of x is also convergent. So now see this, and integral from the limit is 1 to infinity z dx, which is equals to integral from 1 to infinity 1 upon x raised to 3 by 2 dx. In this case n is greater than 1, is convergent. ओके बरोबर आहे. दिगंबरी ओंकार बिराजदार, सकीब शेख एवढेच मुलं आहेत का रे ऑनलाईन? गणेश पाटील, सीमा ठाकूर. So by the comparison test second, we can say that integral from 1 to infinity f of x dx or f dx, which is equals to integral from 1 to infinity f means what? Dx divided by 1 plus x into root x convergent. See this. Thus we can use the comparison test. समजता ना student? Okay, now we shall discuss the next. Okay, now we shall discuss the next problem, problem number 6. Integral of 1 to infinity dx divided by x raised to 1 by 3 into 1 plus x raised to 1 by 2. Let I is equals to integral from 1 to infinity dx divided by x raised to 1 by 3 into 1 plus x raised to 1 by 2. Student, now you tell me it is convergent or divergent. If it is divergent, then now you tell me its end. At which end it is divergent? So, the given integral is improper at right end. So, we have to check convergence at right end, means at infinity, convergence at infinity. Now, let suppose f of x is equals to 1 upon x raised to 1 by 3 into 1 plus x raised to 1 by 2. Now, consider the function g of x, the function g of x which is equals to, now we consider the another function g of x which has the same behavior. Suppose f of x equals to 1 upon x raised to 1 by 3 into 1 plus x raised to 1 by 2. Now, we shall take the same comparison as like this. We have to take the equivalent function or same behavior function as like this, x raised to 1 by 3. Now, 1 plus x, see this 1 plus x is considered as a x, means x raised to 1 by 2. X raised to 1 by 3 into x raised to 1 by 2 means which is equals to 1 upon 1 by 3 plus 1 by 2. 5 by 6, x raised to 5 by 6. Consider this is a g of x. So, 1 upon x raised to 5 by 6. This is very important because by using this function, by using this comparison, we can find the value of convergence. We shall discuss the convergence of f of x, that is integral from 1 to infinity f of x dx. He has the same behavior. With f of x. So, now we shall take the limit. We have to find out limit. Now, limit x tends to infinity f of x divided by g of x, which is equals to limit x tends to infinity 1 upon x raised to 1 by 3 into 1 plus x raised to 1 by 2 divided by 1 upon x raised to, what is the value of g of x? 5 by 6. So, we can take limit x tends to infinity 1 upon x raised to 1 by 3 into 1 plus x raised to 1 by 2 into x raised to 5 by 6 divided by 1. So, limit x tends to infinity x raised to 5 by 6 divided by, we can write x raised to 1 by 3 into 1 plus x raised to 1 by 2. Now, if we take a common x from the bracket, त्या bracket मधनं x common काढा रे students. So, limit x tends to infinity, numerator as it is x raised to 1 by 3 as it is. If we take a common x from bracket, but there is a bracket raised to 1 by 2, so common term will be x raised to 1 by 2. Then in a bracket there is a 1 upon x plus 1, again a bracket raised to 1 by 2. If we take a common x from this bracket, common x, take this common x from this bracket, then we get out of that bracket x raised to 1 by 2. So x raised to 5 by 6, which is equals to limit x tends to infinity x raised to 5 by 6 divided by x raised to 5 by 6 into 1 upon x plus 1 by x. 1 bracket raised to 1 by 2. So this will be get cancel, limit x tends to infinity 1 divided by 1 by x plus 1 bracket raised to infinity, that is 1 divided by 0 plus 1 bracket raised to 1 by 2. As x tends to infinity, then we can definitely written as 1 by x tends to 0, students. So we can write 1. So we can write this as a 1. Therefore, limit x tends to infinity f of x divided by g of x, which is equals to 1. F of x divided by g of x, which is equals to 1. So we can write this as, यालाच आपण असं म्हणू शकतो की लिमिटची जर व्हॅल्यू 1 आली, then according to the comparison test, f of x and g of x has the same behavior, and here in this case, and integral from 1 to infinity g of x dx, which is equals to integral from 1 to infinity 1 upon x raised to 5 by 6 dx. Here n is less than 1. मला सांगा बरे, आता हा कॉन्वर्जंट आहे का डायव्हर्जंट आहे? दिस इज अ डायव्हर्जंट, because if n is less than 1, then it is a divergent. Therefore is divergent. आणि आपल्याला नियम काय सांगतो पहा, लिमिटची व्हॅल्यू जेव्हा 1 असते, if the value of this limit is equals to 1, that is L is equals to 1, then by the comparison test second, f of x and g of x has the same behavior. F of x and g of x has the same behavior. That means we can say that if g of x divergent, then we can say that f of x is also divergent. Then by the comparison test second, integral from 1 to infinity f of x dx, which is equals to integral from 1 to infinity 1 dx divided by x raised to 1 by 3 into 1 plus x raised to 1 by 2 is divergent, or we can write diverges. Okay, in this way we can obtain the solution of this integral. अशा पद्धतीने या इंटिग्रलचा आपण solution find out करू शकतो students. Okay, now next we shall discuss the next problem, that is next. Okay, problem number 7. Say this: integral from 0 to infinity tan inverse of x into tan inverse of x divided by 1 plus x to the power 4 bracket raised to 1 by 3 dx. Now we have to discuss this. This integral is improper. Student सांगा रे कुठल्या कंडिशनला हे improper आहे? Let I is equals to integral from 0 to infinity x into tan inverse of x divided by 1 plus x raised to 4 bracket raised to 1 by 3. This integral is improper right hand. So we have to check the convergence at infinity. Okay. Now let f of x is equals to x into tan inverse x divided by 1 plus x raised to 4 bracket raised to 1 by 3. Now we consider the another function. See this tan inverse x divided by x. Tan inverse x divided by x, we can consider this as a n tends to infinity, then we get the value as 1. So we can consider the function g of x, which is equals to, we can write this as 1 upon x raised to 1 by 3. See this tan inverse x divided by x means this x get cancelled. If we consider 1 plus x raised to 4 as equals to x, then we have to consider another function which has the same behavior, x raised to 1 by 3. याला आपण काय केलं, सेम बिहेवियर मध्ये कन्सिडर केलं x raised to 1 by 3 मध्ये. Okay, so we consider the g of x is equals to x raised to 1 by 3. Now limit x tends to infinity f of x divided by g of x, which is equals to limit x tends to infinity x into tan inverse x divided by, what is that value? See this, 1 plus x raised to 4 bracket raised to, okay, then 1 by x. So okay, yes, ठीक है, x raised to 4 bracket raised to 1 by 3 into x raised to 1 by 3 upon 1. बराबर है. So it can be written as the limit x tends to infinity x into x raised to 1 by 3 into tan inverse x divided by 1 plus x raised to 4 bracket raised to 1 by 3. Now you can take a common x raised to 1 by 3. आता काय करा रे, x raised to 1 into x raised to 1 by 3 means x raised to 1 plus 1 by 3, that means x raised to 4 by 3. So we can write x raised to 4 by 3 into tan inverse x divided by, आता इतना हाईएस्ट पावर कॉमन काढा ब्रॅकेट मधनं, x raised to 4 कॉमन काढा, x raised to 4. If we take x raised to 4 common in a bracket, then we get 1 upon x raised to 4 plus 1 bracket raised to 1 by 3. So we can write limit x tends to infinity x raised to 4 by 3 into tan inverse x divided by x raised to 4 by 3 into 1 upon x raised to 4 plus 1. So we get limit x tends to infinity x raised to 4 by 3, x raised to 4 by 3 will be get cancelled, tan inverse x divided by 1 upon x raised to 4 plus 1 bracket raised to 1 by 3. Tan inverse x tends to infinity, then value of tan inverse infinity means pi by 2 divided by 0 plus 1 bracket raised to 1 by 3. Okay, no problem. So it is a pi by 3. we get limit x tends to infinity f of x divided by g of x which is equals to pi by 2 आणि मग हा pi by 2 झाल्यामुळं and it is the value of L. L is suppose greater than non-zero. L is non-zero. So g of x is equals to, and integral from, what is that? F of x 0 to infinity g of x dx, which is equals to integral from g 0 to infinity 1 upon g of x म्हणजे किती आहे रे स्टुडंट 1 upon x raised to 3. कॉन्वर्जंट आहे का डायव्हर्जंट आहे सांगा रे. x raised to 1 upon 3 dx for n is less than 1 is divergent. So by the comparison test first, therefore by the comparison test second, the given integral is suppose I is divergent, and hence we can prove. ओके, अशा पद्धतीने हे इथं प्रूव्ह होतं. ठीक आहे, मी तुम्हाला होमवर्क देतो, होमवर्क घ्या. होमवर्क प्रॉब्लेम नंबर 8, इंटिग्रल e raised to 2 to infinity dx divided by x into log x into log of log x. याची हिंट सांगतो. हिंट, पुट t is equals to log x. अगोदर t is equals to log x घ्या. t is equals to log x घेतल्यानंतर येणारं इंटिग्रल काय येतं? I is equals to integral from 2 to infinity dt divided by log t येतं. असं सेम आहे, स्टँडर्ड फॉर्म आहे ना, 2 to infinity. आणि मग इथं f of x झाला आणि याची व्हॅल्यू कंपॅरिझन करत असताना त्याला x raised to t घ्या. t म्हणजे 1 upon log x, t घ्या, त्याच्यानुसार तुम्ही कंपेअर करा, याचं सोल्युशन येईल. नेक्स्ट प्रॉब्लेम मी हिंट सांगतो आणखी. 9th इंटिग्रल फ्रॉम 0 to infinity x raised to n minus 1 divided by x plus 1 dx. 10 so we can write 10 integral from 0 to infinity x divided by x cube plus 1 dx. x cube plus 1 dx. 11 integral from 1 to infinity x square plus 1 divided by x raised to 4 dx. ठीक आहे, अशा पद्धतीने एवढे प्रॉब्लेम तुम्ही होमवर्कला सॉल्व करा. इफ यू हॅव एनी डाऊट, जर तुम्हाला कुठलाही डाऊट असेल तर यू कॅन आस्क. तुम्हाला काही जरी डाऊट असेल तर तुम्ही विचारू शकता. नाउ वी शॅल स्टॉप हियर. नमस्कार, गुड बाय.